Morning, everyone. Yeah, ready. So my name is Dirk. I work for Zeros. I design high-density networks. I'm not here to talk about products, so I'm just going to give you a few design principles I use, and I think they are proven in high density. So, what is a large public venue? It's a perfect storm of devices and applications. So you never know what to expect when you go into a large public venue. You can have any kind of application, any kind of device. So what is a large public venue? Can be a stadium, an open field, so an outdoor event like music festivals or any other events outdoor. It can be an arena. It's generally indoor, looks like a stadium, but sometimes easier to mount stuff than in a stadium. Or it can be a convention center. You can have keynotes, classrooms, all kinds of high-density situations where a lot of people gather in one location. So, from what I've seen in large public venues, there are some challenges. So, first of all, there's a high user and device density. So, lots of people in one place. Your design needs to be scalable for different kinds of devices. So, a smartphone doesn't have the same requirements as a laptop in most cases. So, you need to design for both. Our spectrum management. Very important. If you have a lot of devices, a lot of radios, it's easy to fill up the spectrum. Okay. In a design, you also need to build in some flexibility for temporary events. So in most convention centers, you have a fixed installation, but for some events, they also require some extra radios in some locations, so you need to design for that as well. Infrastructure needs to be capable to handle any kind of device, basically. That is a big challenge in LPVs because you never know what kind of device you'll have, so it's unpredictable. And then for most convention centers, it's quite flexible, so the installation time and costs needs to be minimized. So what I use as design principles for bandwidth for events is 1 megabits per second per user, sorry, for basic internet access. And then if you want to do video, I take 2 to 4 megabits per second. Some guidelines. This is from a real event. For demos and for speakers, you want to dedicate some radios for high performance or high throughput. And then for the free Wi-Fi at an event, I take 60 to 200 users per radio. But most of the time I take 70, so total number of users divided by 70 is the number of radios you require, actually. Now this is just a list of what I see as best practices if you design for high density. You want to maximize 5 gigahertz. Everybody knows that. Yeah. We have a lot more channels in 5 gigahertz than 2.4. There's still 2.4 out there, but I see a lot of customers who just switch it off during an event. They just offer 5 gigahertz. Disable 11N bonding. I use 20 megahertz channels because it's all about frequency reuse, right? So I want to be able to reuse my channels. Limit the SSID count. So you all know that when I add SSIDs, I add management traffic, which is sent at the lower data rates, so use a lot of airtime. Turn off 11B. Still a few devices out there, but not that many, so if you can switch it off, switch it off. You also might want to filter traffic. So most vendors have some kind of filtering mechanism on the APs to get broadcasts off the air. Or very chatty protocols like MDNS. You really don't want that on a Wi-Fi network or NetBIOS. Rate limit clients is a good idea in some cases. So you want to avoid that someone just starts to fill up the channel by doing downloads, and so you just limit the data rates. Now this is a big one, the IP addressing. So for events, what I see typically is that they use one VLAN for the free Wi-Fi, and you get 16,000 devices in one broadcast domain. Yeah, so big challenge. You can handle this by doing layer 3, of course, layer 3 roaming, but that just adds overhead. Okay, the internet pipe. I get a lot of questions from customers, and they just tell me, well, I need 6 megabits per user, and I'm going to have 3,000 users on the Wi-Fi, and then I tell them, what's your internet pipe? And they go like, 100 megabits. So the Wi-Fi is not the bottleneck there. Okay, channel planning. Auto channel is the easy way. I like to do it manually, or I run auto channel and then I just check it. This auto channel works fine in most cases, but if you want to do it manually, if you have time to do it, that's probably the best way to do it. Okay, you might want to change your design a little bit if you have specific areas. So we use a lot of directional antennas, especially in stadiums, because you just can't use omnidirectional antennas if you want to focus the energy. Okay, physical location. I think it's best to bring the radios to the clients instead of having APs all over the place. Just put them where the people are. Use mounting locations. So most of the time it's a real challenge, especially in stadiums and arenas. Only a few ways to mount stuff: on the roof, under the concrete, or under the seats. So only 3 options there. Now what I also do is a baseline survey. So I just pick a specific area. I use my air magnets and just do a quick survey, and then just try to replicate that across the venue. Concurrency, I take about 50%, so 50% of the devices as concurrent devices. That's what we typically see at events. Captive portals. Who likes captive portals? I don't. No, they can be a hassle, yeah. Especially if you use inline captive portals where all the traffic goes through the portal. Yeah. Try to put 20,000 people on the network and you'll see what happens. And then, last but not least, implement a wireless policy, which is what most customers start to do now. You just build up a contract with a customer and they say, we only offer 5 gigahertz. If you want to do 2.4, go ahead, but I don't care. Okay, big challenge. As you all know, Go channel. We all know what AP Go channel is, or radio Go channel. There's also the client Go channel. You know, you have a lot of MiFi devices and smartphones just tethering, also fills up the spectrum. Okay, some examples. This is what I did for keynotes. This is, of course, our product. I'll tell you more about it. It's multi-radio. I just put it in a box, a wooden box, and I just take out a chair and put it in the box. And this is what it looks like for a keynote. That's 15,000 people there. And I actually use the people as attenuators. So we call it the FBS, fat belly syndrome. Works pretty well. Stadiums, probably the hardest places to cover. Which stadium is this? Anfield, yeah. So only a few options there. You can go under the concrete, under the seats, or from the roof, or a combination of all three of them. It's quite challenging. Okay, last slide. This is a sample of a wireless policy from a customer. So it's about controlling rogue access points at an event. So they actually have a zero tolerance policy in place. So you are not allowed to bring in your own access points. If we need to remove it or locate it, you'll get a big invoice. Yeah, and they actually push that. Yeah. They actually force customers to sign the policy. Don't bring in your own access points. Okay, 2.4. Some customers still offer it. Others just say, well, no, we only offer 5 gigahertz. If you want to do your own stuff, it has to be 2.4. Which is a good thing, because most of the time it works. Yeah. If all the rest is 5 gigahertz in the venue, I bring in a 2.4 access point. Perfect. Okay, oversubscription, 1 megabit is what I offer most of the time. Hotspots, can be anything, can be a phone. I actually did a test in a big hall with my phone. I just put it on the ground, started up my personal hotspot, and I started walking with air magnet. It's amazing. It's really amazing what it causes. So it's not only about the code channel on the access points, it's also the devices, which cause a lot of problems. Okay. And then, yeah, number of standby APs, which is what most venues do also. Whenever there's a need for extra capacity, they just put in extra access points. And what I tell them is just to reserve a channel in 5 gigahertz. So they reserve channel 36, for example, and then just put out temporary access points only on channel 36. Okay, that was my last slide.
All right. Before he's done, one question. When you said design was 1 megabit or 2 to 4 megabit, are you talking about actual throughput or signaling speed?
Throughput.
Actual throughput?
Yeah.
Thank you.
So without bounding, if you put 70 users on a radio, that's about 1 megabit. That's what I take as a number.
Thank you.
Well, thanks for your time.